So there's a question from the audience. That is, do you think domestic battery energy storage systems can be significant in solving the current issues?
Not so battery energy storage system alone can't solve this problem. Actually, so battery energy storage systems can solve the storage issue for some extent. The graphs I showed you in dry season, wet season, and windy seasons, you can think, you can remember. Even with energy storage systems, some renewable curtailments have to be done. And also, if battery energy storage systems will come, they should come with grid formulas to give some sort of inertia support, but that will support to some technical problems, but we should have. So inertia problem will not fully solved by battery energy storage system. It may give some support if it come with the grid forming inverters.
Yes, sir. Thank you. Also, there's another question about hydrogen-based economy, sir. The question is, what is the future of a hydrogen-based economy and how does it compare to solar and wind as renewable energy sources?
Yes, so in the world, actually, this is the hydrogen, green hydrogen, usage of green hydrogen is, so some parts of the world, they have implemented some cities, those running only with green hydrogen. And in Sri Lanka also, we are talking about going for green hydrogen, especially the Sustainable Energy Authority. Chairman of Sustainable Energy Authority was always talking about green hydrogen. So if it compare green hydrogen with renewables, actually green hydrogen itself a storage. So we use hydrogen as hydrogen fuel. And also we can burn hydrogen. We can use hydrogen as a hydrogen cell. And also we can use it as fuel also. So with the technology improvements, we may use the hydrogen fuel directly burning in power plants. Those supply inertia and primary regulation and secondary regulation as well. So it is a very good option, and so we have to keep room for green hydrogen like emerging technologies as well.
Okay, sir. Thank you. Also, there's another question. Question is, when designing the BESS for frequency control, which parameters of the BESS are considered?
That is out of my expertise actually. So actually, I am not involved with this because I have experience in hydropower plants and thermal power plants. And now I am doing some transmission network expansion projects. So for these specific problems, if we can get connected, some engineers are connected. If Navodhan is here, so can Navodhan raise your hand? So if you are here, so he is involved with that BESS project. So it is coming as a 100 megawatt battery energy storage system in Colonnava. It is under procurement stage. So it comes with a grid forming inverter. So
okay, shall I give some explanation?
Yes.
Yeah. Actually, I'm the Deputy General Manager System Control Center. This 100 megawatt hour battery bank is specifically used for frequency controlling. I think Mr. Saumya tries to explain the concept of battery energy storage systems. Now here you can see the comparison he showed to you about the other battery storage systems. All are 100 megawatt, 400 megawatt hour, or 10 megawatt, 40 megawatt hour. That means the 4-hour duration. This particular Colonna battery is a 100 megawatt hour means within 1 hour you can discharge. That means charge and discharge. That for the frequency controlling, we need the very high, that means megawatt per second. So megawatt, normally if the frequency will change, we have to have the grid support for the seconds range. And that should have a very high ramp rate. Now that particular battery banks chemistry will help you to charge and discharge at a very high rate. That's why this column hour battery bank for 100 megawatt hour that need the higher capacity as well. Now, when you look at the 10 megawatt and 40 megawatt hour battery, that will mainly purpose is to load shifting. But 100 megawatt, that means within a very small time, you can change. That means the battery can support 100 megawatt to the system as well as that is like a plus minus. Now, I think very clearly Mr. Saumya showed you about how to control the frequency through the upper Kotmale power plants. And normally we keep it at 50 hertz and it will operate at some middle range like 67. He showed very clearly about 30 megawatt. Like in the battery, this particular battery will normally operate around 40 megawatt range. Then whatever the frequency support need for the high ramp rate, it can go to plus side, as well as if the frequency goes other way, it can go for the discharging cycle as well. That means I think the main parameter you have to look into the battery could facilitate the very high charging rate as well as the very high discharge rate. Because of that, normally these batteries are rated as the 1C, not like 0.25C in normal other batteries. That's the simple response I can give it to you. But if you need the more parameters, you can go through the bidding document. It's available in the website. Then all the other detailed technical things are available. I think this will sufficient for up to now. Thank you.
So there's another question regarding BESS, and the question is, will
Yeah.
the BESS have a black start capability?
Yes, this column battery will have the black start capability. Now that's the duty of the frequency controlling battery bank. That means, but when you look at the black start is one thing, and restoration is another thing. Black start means you can get the power by itself. Now let's say if the Upper Kotmale power plant will have black start capability, means there is an auxiliary generator or standby generator to support the auxiliary power to the particular power plant, and power plant can switch on to the system without any other external support. Now, same way battery bank will have the black start, but our case is battery should able to support the total power restoration after blackout. Restoration also you can do it through the battery bank, but for that you need to design the battery. Now let's say if it's a column-hour location, then what kind of grids we will try to energize through the column-hour, mainly our Colombo network. That means that battery bank controls should able to overcome the cable charging effects as well. Now, for this particular column-hour battery bank, we have requested frequency controlling as well as the blackout restoration. I think black start is a different thing. Black start means when the power plant is at zero, by taking their auxiliary power through the system, that means through their own system, that should come into the system. Now in column-hour battery, if we want to do the blackout restoration, we should every time we have, from the system control point of view, we have to ensure there is a minimum capacity we have to keep in the battery bank without discharging. Now for that, we have identified around 30 megawatt. That means now 100 megawatt battery bank, we will ensure during the system control operation, it won't reduce to the 30 megawatt. Every time we are keeping 30 megawatt, that 30 megawatt will use for black start plus the blackout restoration. Is
Okay,
it
sir.
okay?
Yes, thank you, sir. Also, there's another question, sir.
Okay.
That is, with increasing electrical vehicle penetration in Sri Lanka, how can we address the potential issue of higher nighttime demand due to electrical vehicle charging and its contribution to the duck curve challenge?
I think Mr. Saumya will respond for that one. I think he not respond. Okay.
Okay, thank you very much.
Okay.
Can you repeat that question again? So I will try.
Yes, sir. The question is, with increasing electrical vehicle penetration in Sri Lanka, how can we address the potential issue of higher nighttime demand due to electrical vehicle charging and its contribution to the duck curve challenge?
Yeah, so actually our ministry has appointed the committee to give a special tariff for the EV charging. So actually then present situation also will be considered in that deciding that tariff. So that committee has been appointed. That committee will consider all these things and decide the time of tariff for electrical vehicles, considering these things also. With the present situation, actually, that in time of use tariff, we have given a low rate in after 10 o'clock now, in off now. But we can get the support of them if you promote them to charge their vehicles in not in Saturdays, in holidays, in daytime. So that committee will consider those things, and that this is.
Okay, sir. Thank you very much. And so there's another question. Why do we need to install synchronous condensers at the generator end? This question was raised because our mandatory transmission plan has included the installation of 70 synchronous condensers at Mana and Habarana.
So actually, that synchronous condenser give the support as well, and also it's up to control the voltage and reactive power. Also, so that's we use synchronous condensers. The presently actually so though we don't have synchronous condensers, we use new Lakshapana generators as synchronous condensers. We keep that generator on bus connected to the system to it mainly to get the inertia support. And also synchronous condensers used to work compensation, voltage control and reactive power control as well. If Buddhika can add something for this, so it's better.
Yeah, actually, we have to install these synchronous condensers mainly to improve the voltage through the reactive power compensation. Then when you look at the longer transmission lines, that would be the ideal places to install the synchronous. That's why there's in transmission plan, they have identified Hambaranam and Anuradhapura likewise our longer transmission lines. And other main thing is if we try to draw the Q VAR generation through the lines, that will have a huge loss. Will have. That means, let's say, if we are taking the VARs from the hydropower stations or the thermal power plants, and your VAR compensation is at the Colombo or the loads maybe at these Mana they have selected because of there is huge potential in future for the wind development. Then the Vaunia, these grids, they have identified the solar generation. Then at the generation point itself, this compensation can do through the synchronous condensers. That's why the planning branch has selected these locations.
Okay, sir. Thank you very much. The next question that was raised was, can we expect better dynamic performance from pump hydro compared to conventional hydro, other than its primary goal energy storage?
Shall I explain?
Yeah, but
Normally, pump hydros will use the variable speed drives. With the VSDs, you can have a very good frequency controlling property. That means the ramping up, ramping with that means now normal our conventional hydropower plants are not designed for that kind of means the variable renewable energy support. These pump hydros mainly you can use for the support aspects. That's the main difference between the pump hydro and the normal conventional hydro. Because conventional hydro, normally we will have a more inertia support system, but the response time is high. In a pump hydro stations, since we are having the very big capacities now, normally in this Mahawaya project, they are looking at around 200 megawatt or 150 megawatt. That means you can get a very good frequency support system through the, it's a somewhat difference with when you with the conventional hydro. Mainly they use the variable VSD drives in the pump hydro systems.
Okay, sir. Thank you very much. And the next question that was raised from the audience was, as per the present scenario, we have approximately 50% of for renewable energy, and with LNG in near future, can't we achieve the 70% renewable energy target? As LNG plants are synchronous type, will it give more stable power than wind and solar?
Right, LNG is not an energy source. Actually, it is a low carbon option. So we don't consider natural gas as a renewable energy. It is a fossil fuel actually. But it's we can with two and more renewables, we have to run some gas. If we have enough hydropower plants, we have to run some gas turbines as well. So to maintain the inertia. So because of that, we should go for LNG to reduce the cost, and it is a low carbon fuel option, but it is not renewable. So renewables are different actually.
Okay, sir.
And also you should have a better mix of generation sources in a power system to operate the power system in a stable and reliable manner.
Thank you, sir. And the next question that was raised from the audience was regarding the plan to reach 70% renewable electricity by 2030. You've indicated that approximately 2 billion USD is required for transmission network upgrades. Given that most utility-scale solar and wind potential is in the northern and northwestern regions, which specific transmission and grid upgrades have been identified?
So actually, to absorb large-scale renewable energy power plants in northern region, the transmission planning branch has planned to have a 400 kilowatt backbone line from Vaunia to Haberna, I think. If I am not correct, please Buddhika correct it. So actually, it should come to absorb the mega scale power plants have to come from northern region, some in Jaffna, Mana, Vavuniya, Poonarin, Poonakari like areas. But under my project, we have already started to construct transmission line from New Anuradhapura to New Haparana. It can transmit about 1,200 megawatts actually, with keeping n-1 the reliability. Standby line and with running transmitting power from one line, we can use n-1 is that. So we keep spare one. So 600 megawatt of power can be transmitted from. So it will be completed within another less than 1.5 years actually. So it can help to absorb many power plants in 1 megawatt to 10 megawatt range. Those will be connected to grid substation in other region. But to get mega projects, the power of mega projects in renewable energy in hundreds of megawatts, as we are talking about. So you know that Adani project was came, that was about 600 megawatt. So for that kind of renewable energy absorption, that backbone line should come, 400 kV backbone line from Vaunia to Haberna should come. So recently that Haberna switching station was opened. That in Haberna switching station, the 220 kV network is connected to the 122 kV. The 220 kV and 122 kV network is a bridge. So most of the renewable energies coming in future is connected to 220 kV network. But there's a bottleneck between New Anuradhapura and New Habarana. And also, even that bottleneck, transmission bottleneck is okay. That problem will be solved with that new line. That backbone line should come in future to go for large scale renewable absorptions.
In addition to something I want to add, now we have requested government to look into the new industrial zones in northeastern part of the Sri Lanka by looking at the bus marginal cost of generation. Definitely with the higher RE penetration in the northern and eastern parts, the cost of generation would be much lesser than the cost of generation at the Colombo, that means the Western province. Because of that, we have requested the ministry to look into the possibility of giving some concessional prices in the industrial zone in maybe Vaunia or Kilinochchi or Jaffna part. I think that's the next level to overcome the transferring power, this bulk power from the northern side to the western side.
Thank you, sir. Unfortunately, due to time constraints, we will have to limit the Q&A session. Therefore, the final question for the day would be, is having a nuclear power plant in a country like Sri Lanka economically viable?
Actually, the initial investment for nuclear power plant huge, but now there are new technologies for go for not large power plants, some small scale power plants also. But there is a policy in our country that we are not going for renewable technology, even for energy sector. But that is the policy of the country. Because of that policy, I think our planning branch don't consider nuclear power plants in our plan. So I think Engineer Buddhika was in the planning branch also before come to System Control Center. He may add a little more.
Yeah, no, I think so. Where they are asking the new plan, there is some nuclear. I think they have proposed after 2042 or 2045. I think that's this question was raised. Maybe now when you give as the candidate power plants, normally when they do the generation planning, they will provide the candidate power plants. Maybe at the end of the horizon, that means the 2044, this plant has been, that means chosen as the optimum power plant. Maybe it's a government policy. If the government says no more nuclear, then we may have to go for a look into the different policies, and maybe with this renewable energy policy, maybe this may be changed. But when you look at the generation plan, it has been proposed in year 2044, I think, or 42. I can't remember the exact year. Normally, when we do the optimization, they provide the candidate options. Then these candidate options the best candidate option will come into the plan. That's the way they have taken it. I think Mr. Saumi also very clearly told, normally to construct a nuclear power plant, it may need the long lead time, maybe at least 15 years. Now itself, we have to take a decision. I think this would be an eye-opener to the government to take a correct decision whether to go ahead with nuclear power plant development or not. Another thing is, now itself also, there are nuclear power plants having capacity around 300, 400 megawatt. Previously, these economical capacities were around more than 1,000 megawatt, but the technology has evolved. And nuclear also considered as a clean energy source. Now those are the things they have considered while preparing the generation plan.
Thank you, sir. On behalf of Electrical Engineering Society of University of Moratuwa, I extend our heartfelt gratitude to Engineer Saumya Kumaravadu for taking the time to be with us today. Your thoughts and insights have been truly inspiring. A special thank you also goes to Engineer Pawara Abekon, who coordinated and made this session possible. And finally, thank you to all the participants for joining us. We hope this session has been both educational and engaging. With that, we officially conclude today's program. Wishing you all a pleasant evening ahead.